Good to see everybody out after the party last night. Hope you had a good time. We're here today to talk about my favorite little language. It's called JavaScript. You might have heard of it. This is a language that's been around for nearly 20 years. And when you think about it, 15 years ago, 10 years ago even, this was kind of the Rodney Dangerfield of languages. It got no respect. This was the little dinky toy that you used to build tic-tac-toe games on your websites or make things blink and flash when people clicked buttons. But for the largest part, it was a language that was never really taken seriously until somewhere around, I'd probably say 5 to 7 years ago, as the internet and web browsing became a lot more interactive from an application development perspective. We transitioned from this world of static web pages to very rich, engaging web applications that didn't need to refresh and post back to the server all the time, and for ones that allowed you to do some really interesting things on the screen. It's overall a very C-like language. If you're looking at it and you come from a C# or Java world, you're looking at it and saying, yep, no, that looks pretty familiar. There's an if statement and a function call. But bear in mind, as much as this looks like something like Java, it's got about as much in similarity or in common with Java as cars do with carpet. They share the same name in it, but that's really about it at the end of the day. On the web, and this is where many people are encountering JavaScript for the first time, this is what provides behavior. So you've got HTML, which is your markup that describes your content. You got your CSS, which is focused on layout. But JavaScript is really around behavior. And what's made JavaScript more interesting, and just for you guys at the back, there's some seats at the front here. What's made it more interesting within the last couple of years are the advancements in the browser engines. Where before we had slow interpreting browsing engines that were, when you got to a certain point of complexity, you could just feel the page slow down as it loads. We've gotten beyond that with Google getting into the game on their JavaScript engine, with the guys on the Firefox side stepping up, and even the IE team being brought back together after a long period of quietness to help rebuild the JavaScript engine for IE. This has become a very, very powerful technology on the web. And it's coming out of that demand for building richer, more interactive experiences without proprietary extensions. Largely we're seeing, and I'll give Apple a little bit of credit here, the demise of Flash, the demise of Silverlight. People are saying, I want interactive abilities built right into my browser, and it's not just about moving a few things on the screen. It's going beyond that into the latest extensions within the browser world with JavaScript, being able to control things like webcams and do audio conferencing all out of the browser environment. And so we're seeing richer web apps today, things like the new SkyDrive app, where you've pretty much got a full-on desktop experience right on your web browser, along with things like the Office web apps. We're seeing other apps that weren't possible really in this world in terms of a fluid user experience 10 years ago, like Xero. QuickBooks 10 years ago, you needed that desktop experience. Nowadays, you can get it equivalent and better, I would argue, on the web thanks to JavaScript. But it's more than just the web. Investing in learning JavaScript is going to get you everywhere. And this is where I think this is the time to really buckle down and double down your investment on JavaScript, because you can start writing native phone apps for iOS, Windows Phone, for Android using PhoneGap. You can write native Windows apps, as you might have learned at some of the sessions here this week, using HTML and JavaScript and CSS. And you can also build very high-performance server apps using Node.js. This makes it really, really exciting, because they're taking advantage of some of the traits in the language to create very scalable, very fast asynchronous I/O applications. Once again, this is one of those investments that will pay off in spades. But like any language, there are bad and there are even ugly parts to the language. And so, as much as I'd love to say JavaScript is the greatest thing since sliced bread, it's got its problems as well. We're going to look at some of those quirks today, and hopefully just kind of help you understand a little bit about the dynamic nature of JavaScript and how to avoid some of these. Because some of the quirks that you run up against in JavaScript, unless you really understand the why, you're going to sit there and kind of be frustrated with this language And meanwhile, just a quick, simple, aha moment will cause you to take better advantage of that as a language. The language itself also continues to evolve in a number of different ways. We've got ECMAScript, which is the standards around JavaScript coming out. But we've also got people innovating on top of the language. So this is CoffeeScript. It's the same function that I showed you earlier. But you can see syntactically it's a little bit nicer, a little less dense with syntax. And so if you didn't make the session for CoffeeScript that was going on this week, certainly if you're going to get heavy into JavaScript, it's something to take a look at. On top of that, there's a rich system of libraries. And so you're not on your own with just what you get out of the box with JavaScript in your browser. You've got libraries like jQuery that allow you to patch all the browser isms across all the browsers. You've even got libraries out there that allow you to do link-style queries, MapReduce, data binding, MVVM, and MVC type models within the browser. In short, there's just a huge ecosystem of people working on this as an environment, and any sort of problem or challenge that you're trying to tackle, chances are somebody else has already come across it, and there's a wealth of knowledge out there. This is one of the few languages that there really isn't a vendor battle over, where C# is a Microsoft thing and Java is an Oracle thing, and it's kind of Microsoft versus Oracle or Objective-C on Apple. JavaScript's the universal language that everybody supports and everybody wants to see succeed. And that's why you get things like being able to call into Microsoft PSS to get support on jQuery. I don't know how many of you have known that. I find a lot of people are surprised by that, but Microsoft is so committed to some of these libraries, they're providing commercial support for them as well. But enough talk, let's get into some code, and we'll show you some of the quirks and show you some of the things that are familiar about the language so that you can see that, yeah, it's really not all that bad. So we'll start off with some of the just kind of basic familiarity aspects. If you've played with JavaScript before, you'll have seen some of these, but I want to try and give you a little bit of the how and why. And if you've cut and paste JavaScript before, hopefully this will give you an insight into what it is that you're actually seeing when you did that cut and paste. So in JavaScript, and just so for FYI, I'm running Node.js, the command line interpreter here, and this is available on pretty much every OS out there, but it's just a great way to go explore the language. You declare variables and they're vars. Ignore the undefined, we'll talk about that a little bit later. But variables are very much like variants for anybody who's in the Visual Basic world. It's basically it's a placeholder for a type. And those types are really three main types. There's strings, numbers, and booleans from a primitive perspective. And so a string you'd see something like, x equals foo, or x equals double quotes foo. And again, this is something that a lot of developers new to JavaScript will kind of, like, when do I use single quotes versus double quotes? The reality is they're interchangeable, and what it allows you to do is do things like this, where you don't have to escape a certain set of quotes. You can just simply reverse them around and be able to have a nicer visual experience at the language perspective. You can also change types on the fly because this is a dynamic language. So I'm going to change x to an integer. But that integer is actually also capable of doing floating points. And so in JavaScript, we just call them numbers. We don't distinguish between doubles, decimals, floats, blah, blah, blah. We really focus on the underlying data type being a number. The other thing we get with JavaScript are, of course, your Boolean values. And they're pretty straightforward to work with. You'll also get arrays. Arrays are popular in pretty much every language because they make the world go round. But what's neat in JavaScript, being a dynamic language here, is arrays don't necessarily need to be of one type or another. I can go ahead and mix types in and access in each of those types within the array. If you've used any sort of AJAX or perhaps a NoSQL library, a NoSQL database store, you've probably come across this thing called JSON, or JavaScript Object Notation. And it's really kind of a bag of properties, if you will, a completely public object that exposes properties in key value pairs. And so it looks a lot like this. And similar to the arrays, you can go ahead and mix in the various types and then access it using a property style notation. What's neat about JSON, just in general, this is one of those things that came out of JavaScript that's actually universally usable. We've somehow decided that XML sucks, and JSON has become the new way of sending data around. And on top of that, people are actually using JSON as storage formats. And so I made a mention of NoSQL. If you look at some of the document database stores out there, they actually are storing the data in a binary JSON format so that they don't have to deal with type conversion and all of the headaches that come along with that. They just use the JSON spec to be able to handle a lot of that for them. So JSON is something that even if you're not going to dig into JavaScript deeply, is just a really useful data storage, data representation format. And it's one of those things where you can get parsers in pretty much any language out there, including a very popular one for C# by one of your own native New Zealanders, James Newton King. No props for the nativers, go New Zealand. All right, just want to make sure you're awake. So outside of the kind of more primitive types, we've got a couple of key objects that you'll come across. How many people use regular expressions on a regular basis? Good, there's about half of you. For those that you haven't, regular expressions, boy, they're just awesome is all I have to say. So JavaScript's got native capability for regular expressions, and there's a couple of ways to access it. The way that you'd see in the textbooks is by creating a new regular expression object and then simply passing in the regular expression itself. So in this case, I'm just creating an expression that will go parse out 5 numbers. And oops, let's just clear the screen. We'll do that again. And we'll go ahead and I'll show you just a test to see if that matches the regular expression. It does. But the more interesting way and the more Perl-like way, if you will, of working with regular expressions is actually just to do it in line. So I'm going to write a regular expression here that parses out the price or a decimal value here. So I'll take a decimal, a dot, and then I'll go ahead and, oops, sorry, I have butterfingers here today. All right, and we will do another decimal after the dot, and we'll capture that as many times as possible, and we will close that off. So the new regex and this other one are exactly the same. JavaScript just knows that if you start any sort of variable declaration with a slash and end it with a slash, is that this is a regular expression. And so you can go ahead and parse text with that regular expression. So let's say the price is $55.99, and it goes out there and parses out the value $55.99. It starts at index 14 in the string and echoes back your input. But of course, this gets really interesting when you need to do string operations. So actually, right on the string is also a plugin for the regular expression. So let's do $55.99. So there's my string, and I'll go ahead and call match on it with the regular expression, and it will parse it out. And of course, the reason why regular expressions become uber useful outside of validation is search and replace. So for example, I want to go replace that with $24.99. No problem, I can do that with a call to replace off the string. So regular expressions just natively built into the language, super useful. For those of you that don't use them on a regular basis, highly encourage you to take a look at regular expressions in action. Let's get into dates. Dates in JavaScript as well are there part of an object. You can do new date, and that will give you today's date in the current time zone. You can also call out specific dates using a constructor style syntax to get a specific date. That's December 26th. I bet you I got my syntax here backwards, no problem. We'll continue on here. So let's go ahead and blah, blah, blah. Nope. Node, all right. So let's do some date arithmetic here. So I'll go ahead and get today's date, and I will subtract a couple of days from the date. So let's take 7 days off. And of course, that's the actual underlying representation. If you're used to Excel and serialized dates, that's kind of what it looks like under the covers. It's a Unix epoch, and that's a whole other conversation. But I just took 7 days off that particular date. So date handling is pretty native inside JavaScript and works pretty well. Again, if you're doing a lot of heavy stuff, there's some great libraries out there that allow you to do that. For those that are familiar with any sort of C-style language, of course you've got things like your for loops. or sorry, your if blocks that allow you to do control structures. Oops. And then, of course, we've got bitwise operators as well. So you can say 2 plus 3 equals 4, or 4 plus 5 equals 9. If one of those are true, go ahead and execute the function here. Pretty simple. Outside of that, we've got while and do while loops. I'll just go ahead and I'm going to paste these in because they're not really all that interesting. And if you've seen one before, you've seen a million. Oh, keep forgetting my screen is so big here. It's not doing what I want. All right, we'll type it out here. So so you can do while x is less than 5, console.log x plus plus. And so you see things like there, like your increment operators that you'd be used to in a C# or a C++ type world, or a Java world even. And of course, you've also got the do while loops, which behave very much like it does in any other language out there. All right. So there is one little thing that I do as we go through control structures. The reason I want to review this because there's one type of control structure that's a little bit different in JavaScript from other languages. And so I'll start with the one that actually behaves as you might expect. So let's go ahead and grab an array, put 5 numbers in there, and then let's go start for looping through that array. All right, and you've got all your usual loop type things where I can say, if it's divisible by 2, or if it's not divisible by 2, continue over, otherwise log out the item. So that's a pretty straightforward for loop. Outside of in C# where you might put int, or actually I guess now with C# 4 and beyond, I can actually pretty much almost cut and paste that into C#. But there's another type of loop that's a little bit different, and that's the for in loop. And I've seen again, kind of doing code reviews and seeing people try and translate their static typed experience into JavaScript. This is actually a special type of loop that's reserved for traversing objects. So let's take a look at a for in loop. So let me go get a bit of JSON. So we'll say x is equal to first name Chuck, last name, if I can type here, Norris. So there's my array. So the for in loop is actually very special. So if I for in over the x, what you might think is I'm getting back each value kind of one at a time, or each kind of object. And what I'm actually getting back is the key as part of the key value pair. And this is kind of it's really not meant for general array traversing. It's meant for inspecting objects in a much deeper level. So I can use it to do things like output the contents of a JSON array onto the screen, or go and inspect it. Oops. All right. Sorry about that. Console.log key, then x key. And so it allows me to there and traverse that. So that's one of those things where the for in loop is kind of more about language semantics. It's not about just traversing generally in data. And of course, we've got switch statements. Switch statements look like any other language. One of the ones that the VB folks might be proud to see has made its way into the world of JavaScript is the with function. So if you remember Visual Basic long ago, with just saves you from typing the variable over and over again. So in this case, I'm doing with of this particular JSON object, and all I need to do is type in name, and it will know that it's x.name out of the gate. So that's a little kind of shout out to the VB folks out there. And then finally, the key of JavaScript, and we're going to dig into quite a bit of this, is the functions. So the kind of syntax in JavaScript says functions should always start with a lowercase letter. That's not a language requirement. It's just a style trait that a lot of people tend to follow. And so when you declare a function, you can just go ahead and call it like you would. But you'll notice there's no return type there. So if I want to, for example, create a function like add and add up A and B, I can simply do that and return it without having to declare any sort of particular function there. So I do add 1, 2, add A, B, and hey, check out that just a little slight, it's a small thing, but I'm able to write general purpose functions, and this is what I love about dynamic languages. Add doesn't really care if it's a number or a string. It's able to operate on really any type out there. And so as we dig through into some of the further quirks, that's one of the really powerful, simple but powerful aspects of JavaScript. But let's talk about some of the things that really trip people up in JavaScript. And one of the ones that a lot of people run into challenges with when you first start looking at JavaScript, and it's because of that dynamic nature, is equality. So I think we can all pretty much agree that 1 is equal to 1. Pretty fair? So in JavaScript, 1 is also equal to the string version of 1. 1 is also equal to the word true. True is also equal to the word 1. And so what's happening here is on the fly, JavaScript's doing some type conversion. And it gives you some advantage to be able to do things like parse out strings, or not have to parse out strings and clean up variables. For example, when I'm taking number input, I don't have to worry about trimming strings. JavaScript will just do that for me and evaluate out accordingly. You might also, as a result of 1 equal to true, we'll probably also agree that 0 is equal to false. But did you also know that 0 is equal to nothing? And of course, 0 is going to be equal to 0 in a string. So it's these little quirks in the equality that make it really challenging to kind of wrap your head around sometimes, because your code, you'll go and expect one thing, one type of behavior, like people passing in an empty string and treating that differently than a null, let's say, and you'll find JavaScript has slightly different handling for that. And so one of the things that I try and keep by my desk, or kind of keep it at least in my bookmark bar, is the table of conversions. And this will be in the slide deck and available to you guys, and it's a fairly well published chart that exists on a bunch of different places. But this is the thing you need to keep in your mind, and it will help you understand a little bit more about how to better structure your language and your functions around that. But there's some neat things that come out of the side effect, like I can add true and true to get 2. And of course, a true plus a false is equal to a true. So whenever they say a right and a wrong doesn't make a right, well, in JavaScript it does. And of course, if you take away a true from a true, that's equal to a whole lot of nothing. And as you might expect as well, true times 5 is still going to be equal to 5 as well. So there's neat little things like that you're able to do. Let's go ahead and put true through the parseInt function. And of course, there are limits to this. So the parseInt function attempts to read the type and looks more for strict type conversion. It says, hang on, true is not a number. I have no idea what that is, so I'm not going to accept that. So one of the ways to get around that, and again, I don't want you to use this particular type of operator all the time, because it starts to defeat some of the dynamic language features. But we've got a strict type conversion, and so you might have seen the triple equals. And what this is doing is a strict comparison between A and B, and saying that only if A is truly equal to the other one is it true. And so when we evaluate the 1 equals the string version of 1, we get false. Or likewise, if we evaluate the Boolean version, we get false. So just, that's out there, but don't abuse this, because what happens is the more strict equality that you do within your language, it starts to defeat the joys and the awesomeness of the dynamic nature of JavaScript. Let's talk about a couple of other key aspects within the language before we jump into objects and object literals and the fun around that side of the house. So the other one that I want to talk about is null versus undefined. So when you come into JavaScript from a language like Java or C#, when you declare a variable for the first time, it's set to null, but not in JavaScript. In JavaScript, it's undefined. And to kind of play around with this, they kind of work like null is equal to undefined, but but undefined only happens at a certain time. So let's go say A is actually null, And let's just really confirm that. No, it's actually not null. It's undefined. But even though those two are interchangeable. But undefined is something you only get to set once at the initial variable declaration. So if I do a is equal to bar, I can no longer get back to that undefined. So if I set it back to null, and now I can say, is it null? Yep. But is it undefined? It is. But if I do a strict equality here, it absolutely isn't. So undefined is that initial pre-value state. And so just be aware of that. And the reason I bring that up is because if you start doing things like this, triple equals null, to check if something hasn't been set, this is going to break when you just have a var a and you haven't set a value because it's actually undefined. The better way to do this, if you want to check to see whether or not something has been truly not set, that's kind of recommended, is just to say if it's not a. And what this actually means, this is actually called falsy. This will evaluate to true if the value is either undefined, null, blank, 0, or false. So if you're looking at JavaScript and you're wondering why you're seeing this if not variable, it's because people are basically trying to detect if the variable either hasn't been set or has been reset back to null or some sort of falsy type value. And so this is a very common pattern that you'll see in JavaScript, especially when dealing with the browser DOM and you're looking for elements that may or may not exist. This is kind of my catch-all that deals with all the various conditions to check as to whether or not that value is not there. So that's kind of why I bring up null versus undefined, because the way we define that in JavaScript, that will trip certainly folks up. I'll just block that off. Now, let's talk about some of the ugly stuff, and I'll give you a, quick question. False. So if the string was 0, it's considered false. And if it's a string that's just got no value in it, it's also considered false. A string with the word false in it? I've actually never tried that. So that's a good one. But unfortunately, we don't have a whole lot of time to do that. But I do want to show you, kind of some of the things that really trip up JavaScript. So I've got a random function built into the runtime, and it gives me random numbers. But thanks to the dynamic nature of JavaScript, I can do this, which kind of gets a little scary at times. So now the next time I call math.random, it's always giving me the answer to life, which is 42. So it is a dynamic language, and you got to respect that, and it will trip you up from time to time, especially if you're transitioning from C# and Java over to JavaScript. You got to kind of keep in the back of your mind, this is not like what I'm used to when it comes to things like type conversion, equality, and the ability to override things. So that's kind of a little bit of the underlying language semantics. What I want to talk about next is the objects versus functions, because people like to say that JavaScript is an object-oriented language. And the reality is, if you look at the strict definition of object orientation, it actually doesn't meet all the various barriers. I'd like to call JavaScript an object-like language. It has this concept that kind of looks like objects, but things like inheritance don't really work the way that it would in something like a Java or a C#. So let's take a look at some basic objects here to get started, and that might help us explore some of the aspects of JavaScript and help you understand kind of how it actually works. Let's go ahead and create a new object. And so it's called foo, and let's go ahead and add a property on it. And let's go ahead and add a function on it as well. So the first thing you'll notice here is that the functions are treated very much like variables in a lot of ways. So I can say function or foo.hello now, and it will go ahead and run that function. So functions and variables kind of interchange in ways, and again, that's my head explodes, because in C# you'd never do that. Or you'd actually just call them delegates, really, in some aspects. We've also got other ways of defining objects. So that just same function that we defined, we're going to create what's called an object literal. And so you might see it in this format, where it's defined as a variable where name is equal to Chuck Norris, and hello is equal to function console.log this.name. So these are exactly the same objects defined in two different ways. And you'll notice the object literal looks a lot like JSON from a format perspective. Now objects, inside objects, everything is public. There's no concept of private, protected, or anything like that. If you're defining an object or object literal format, everything is exposed to everybody at any time. And of course, just like I showed you with math.random, they can override it at any time. So that doesn't make for building a very robust API or object model. And so we've got this concept of function literals and a mix between function literals and objects that allow us to kind of get more of that class-like behavior. So if you recall, we had functions that we just showed earlier. So I can say console.log name, and voila, I've got a function. But a function literal kind of looks like that object literal, but instead of it just being a JSON array, it's actually a function itself. So this is a function literal that you might have seen. And this actually behaves more like a class. So I've got my constructor here. So my constructor is taking in one parameter. And at this point, I'm now in the execution area of the constructor. And so I'll define a private field here. And I'll go ahead and use my constructor parameter. And I'll go ahead and expose a public function. So I'm getting out of this semantics that look and behave like an object, but again, there's aspects of it that don't live up to the true definition of object orientation. But the neat thing is, at this point, I can just go ahead and say equals new foo, Chuck, var equals new foo, Steven, and then I can go ahead and execute them, and they work very much like objects. And of course, because I've defined certain things as private, in this case, the particular greeting here is actually a private because it's not prepended with this keyword. The this is the magic that kind of says make this public when you're defining it. I can't override things like, so if I try and say hello, it's still going to revert to the private definition there. So the kind of key takeaway there is functions, function literals are kind of your object equivalent in JavaScript, and you're going to see them in a whole bunch of places, and you're going to see people doing some really interesting things, like creating patterns such as the module pattern with them. And so the module pattern looks like this. So we'll get some privates in there. We'll go ahead and actually create a private version of hello, so I won't use the this function, just to show you a private function. And then we'll return selectively what it is that we want to expose publicly. So I'll say return hello, and that's actually a call into private hello under the covers. So what just happened here is I created that object. I created a couple of privates. But when I go ahead and create a new instance of it, it will only return the object literal that exposes the public functions. If you remember before I mentioned, anything that's on the object side of things, everything by default is public. So hello will be public, and if I want to provide other variables or methods, I can do it as part of that return collection. So I can go ahead and say foo equals new foo. And that's going to underline call the private hello. So it's just the function is actually the class. That's, in the back of your mind as you're transitioning from language to language, that's kind of a key point to go ahead and digest. So the next thing I wanted to just touch on is a little bit of, when we talk about these objects, is inheritance. And this is one of the areas that, where JavaScript actually fails the OOP test. And so how many people have seen the prototype keyword kicking around their JavaScript code and probably wondered what the heck that was? So about a good third of you there. So to do inheritance in JavaScript, we use what's called a prototype pattern. And prototype patterns are kind of similar to virtual methods inside your C# classes. You're basically making a public declaration of, this is okay to override. But there are some consequences, of course, to that because JavaScript has some ugly parts, and this is one of them. So let's go ahead and create a base function, if you will, called animal, and we'll say name equals hello name. And then we'll go ahead and expose a public property getter, if you will. So this is Java. Java has a little bit of a shared history here in the sense that we don't have the concept of properties that we have in C#. It's either fields or methods, or functions, I should say. So I'm going to create something that kind of syntactically looks like a property. And so I've got my animal method, and so I can do a equals new animal for Fido, and I can call a dot hello, of course. Oh, sorry, dot get name. I can also go ahead and instantiate a new one, just like any other function. So this one will be Mr. Jangles, for anybody who's got a cat. And of course, one of the things that's really interesting about this particular function, and just kind of one of those memory management things, is when you create these functions, it's basically instantiating everything in memory twice. So the function that I created before, the getName function, actually exists in memory twice. And so if you do an equality across it, there's actually 2 instances in memory. That's a bit of a side effect of it, but let's take a look at this prototype pattern here in a little bit more depth. So I'm going to say on the animal class, I want to create a prototype for the function hello. And by default, I want it to be console.log. And now I need to access something inside the function. The downside of the prototype pattern is it has no access to any of the privates. I can't get to that name variable, so I need to go ahead and call that public version of getName to be able to get to it. So I've declared now a hello function, so I should be able to say hello on that function. And where that gets useful is when it comes to overriding. But before we get there, I just want to kind of show you just why the prototype pattern is really good on a large-scale application, is because prototypes are shared amongst all the instances. So in this case, for every instance I created this object, that function isn't being recreated in memory. So that's why one of the underlying reasons prototypes are really interesting. But let's take a look at inheritance. So I'm going to create a new function called dog, which derives from the animal function. And so what I need to do here at this point is declare my constructor very much like I would in the other one. And so I can I can declare variables, functions, all that sort of stuff. I can also call my parent constructor. And so for those of you coming from the C# world, think of it as kind of the trying to declare a function, or sorry, a constructor that does this. So to be able to call up to that parent, I'm going to say animal.call. I'm going to go ahead and pass in the reference to myself, and then any variables that I pass into that constructor. So that's kind of being able to call the parent constructor, if you will. You don't have to do it, but if you need to, you can absolutely do that inside JavaScript. So I've almost got an object that inherits from animal. At this point, all it does is it calls up to the animal function. I've got a couple of more pieces of ceremony, if you will, to complete the inheritance. The first thing I need to do is tell the dog class that it's based off an animal. So whenever you create a new dog class, underlying in the covers, you need to create an animal. This is actually the thing that ties the classes together. I also need to make sure that it calls the proper constructor. So by default, it will go ahead and call into the underlying animal constructor. I want it to actually call my own constructor. So I'm going to say, when you go ahead to start the constructor, call the dog one. And in the dog one, I call up anyways, so I handle both of them. And now that I'm at this level where I've created this object, I can start overriding things. So let's go ahead and override that hello function that was there before. So similar to how I declared it in the animal side, I'm just going to do dog.prototype.the name of the function. Go ahead and start defining the function. So I'll do console.log woof, and I'll call back up to my parent function, just to show you that inheritance is actually working. Sorry, my parent class, to show that inheritance is working. And then I can even call up to the parent implementation. So similar to the animal.call that allowed me to call the constructor on my parent, I can go ahead and do animal.prototype.hello.call this. And that will call upwards to the, that's kind of your equivalent to the, base dot, it would be base.hello in C#. So let's see this in action now that we've got an animal and a dog. So foo is equal to new animal. This one we'll call Whiskers. And we'll create another one. And I love this name. I saw it at a dog park one day. Somebody was calling their dog Bananas. You know, it's the most funny thing to hear somebody call out, "Hey, Bananas!" You know, so trying to see if you guys are awake. So I can go ahead and call up to foo, and if I call into the bar version of hello, it's going to, as you can see, it called the dog version, then called up because I had that call all the way up. For those of you that might be trying to quickly scroll down the code, I'm going to make all this code available on GitHub afterwards with comments, so you'll be able to see all of these examples in action and play with them yourselves. So, you know, just to do the final test here, foo is absolutely an animal, but foo isn't a dog. But foo is, of course, an object. And this is the thing that, you know, objects and functions are a little bit interchangeable. This trips me up to this very day. Bar itself is an animal, and of course, it is also a dog. So if you're creating any sort of an object model, and as you get into trying to build MVVM or MVC style applications, the prototype pattern is really kind of important. Not just from it allows you to do inheritance and build like, kind of person, employee, client, and kind of that sort of traditional OOP style object model. But it also is really important from a memory management perspective. And so one of the things that you kind of saw throughout there is that when you define everything inside the object before you use the prototype, every time you create a new instance, it's copying that entire thing in memory. And so if you've got 5,000 of these objects to render something on a screen, like a grid or something like that, that's 5,000 copies of that entire class. Whereas when you use the prototype pattern to define all your publics, the nice thing is that it's one instance. And so if you have 5,000, it's really 5,000 data transfer objects, if you will. It just holds the data, and your prototype has a common definition of the actual object itself. So one of the last big things before we jump into the website that I want to just talk a little bit about is scope. And this is also kind of important, especially as you get into single-page applications or ones where the application context doesn't necessarily die on a very regular basis. And I don't know a whole lot about the Windows 8 HTML JavaScript side, but I'm assuming there's areas there where dialogues may stay open for long periods of time. And so you need to understand how scope is handled in JavaScript. So scope by default, when I declare a variable, is global. So at this point, A sits on the global namespace and won't be garbage collected until I kill this instance of Node.js. The equivalent to this on the web is this variable sticks around until I kill that browser tab or navigate to another page. And so that's important, especially when you've got a large number of objects that you're starting to put onto the stack. So let's go ahead and create a function here that goes ahead and accesses that variable. Now what's important here is that this function will never get garbage collected, and it's because it references something on the global stack. And so we've created what's called a closure here, where it's basically the inner function now has become part of the outer function as a result of that reference tying over. A better way to have done this, if you want to get proper garbage collection, is by doing this, where you pass the function in. So it's, again, one of those situations where people get into scenarios where I'll just declare everything as a global scope or a global variable. But when you build enough of these and your app starts to slow down or responsiveness starts to slow down, these things can really hurt you. And all you need to do is a simple design change where instead of referencing that global variable directly, you passed it in through the function. And so that's created effectively a local scope for variable A. And so that's no different than, for example, var A is equal to 3, console.log A. That's pretty clearly local scope. But what about this particular function? Where do you think scope is actually defined in this particular function? In this function, it's actually declared in the function at the function level. It's not within the brackets. So when I run this, what I'm actually going to get back here is the variable 4, not the global variable that I defined. And it's because, and this was kind of one of those aha moments for me when I was working with JavaScript. And this is what made scope, really crystal clear. The scope boundary in JavaScript is a function. It's not curly braces. In C#, for example, anything inside a curly brace sticks inside that curly brace. I can't call it out. This would not be possible inside C#. But in JavaScript, the function is the scope boundary. And so if you kind of keep that in the back of your mind, that's going to really help you build much more performant JavaScript applications, especially, again, single-page applications or ones where you've got a large number of objects instantiated. Just remember, the function is the scope boundary. All right. So we touched on objects. We touched on function literals. Again, I've got this code that I'll put up on GitHub, and I encourage you to use Node to play with it. It's kind of a neat tool. I want to touch on a little bit of the web side of things because I think this is kind of equally important and cool. So let's go ahead and pop open Visual Studio. So I'm just running Visual Studio here, and I've got a page, just a straight-up HTML page. And we're going to play with a little library called jQuery. How many people have worked with jQuery before? Cool, half of you. How many people would consider that you're still learning jQuery? Okay, so I'll go through some of these examples. I just wasn't sure. I don't want to bore you to death with the awesomeness of jQuery. I think it's hard to get bored with jQuery being so awesome, but let's go ahead and give it a whirl here. Oh, JSLint is getting in my way. We will turn off JSLint for a second, by the way, and we'll talk about that in a minute. JSLint is just an awesome validation tool to make sure that you're doing the right thing from a JavaScript side of things. So here's jQuery in a window. Really, not that interesting from a visual aspect of things, but let's pop that out and put that to the side here. By the way, this is, again, one of those things that finally make JavaScript really easy to work around is the fact that every browser out there now ships with development tools built in. These tools, if you're doing JavaScript on the web, get to know these tools. They are absolutely, absolutely essential. No longer do you have to put in alert calls and wait for these pop-ups to figure out where you are. They've got full breakpoint capable inline JavaScript debugging, and what I love the most, obviously, is the ability just to kind of futz inside the browser before I'm, kind of sure what I want to do. So jQuery is this library built on top of JavaScript that makes browsers nicer to work with. Browsers have a lot of quirks. So document.getElement by ID, getElement by name. There's certain behaviors that vary from browser to browser and make it really, really tough to work with. And so if you've ever had to fight with document.anything, and you haven't really discovered jQuery, this is just so much nicer to work with. So instead of trying to work with those browser quirks, they've patched all of them to make it easy to be able to say, go get me all the list elements. And so I just say, $, dot, and then pass in what it is I'm looking for. Or go get me the element that is tagged with the ID equal to main nav. Or go get me elements that have a class of active on it. Oops, I gotta spell active correctly. Or go ahead and get me the children URLs of the nav. So in this case, I actually have two ULs here. It's only going to get me the first one because that's the only one that's a child of a nav element. It also allows me to go ahead and get elements of specific attribute properties. So in this one, go give me any input that is of type password only. Oops, sorry, that's going to blow up there. And so in that case, I got my password. And then they've also got shortcuts for all the commonly used ones like hidden and password and things like that. So jQuery is a really powerful way to go and get access to stuff on the DOM. But once you've got access, you probably want to do some stuff with that. And so that's where things get really, really interesting. So for example, I can wire up events. And events are a key aspect of building interactive web apps here. So I've got a function called onSubmit, and it really doesn't do a whole lot but beyond kind of fire off an alert. So I'm going to go ahead and get the submit button, and I'm going to say on the click event, run this onSubmit button function. So now if I go over here, voila, it runs it. And top of on, I can also say, take it off, get rid of that call. And that's actually something, if you've worked with earlier versions of jQuery, event binding is now officially recommended to use the on-off, not bind, unbind, live, and so on. There's also shortcuts. So for those really commonly used ones, like the click one happens to be one of those events that pretty much everybody uses. We've got the click function that allows us to bind up that exact same event. So I can go ahead here and click in, and voila, there's my function. You can also bind to multiple events as well. Oops. So in this case here, I'm binding to, with the same function, both the mouse enter and mouse leave. But the thing that, and this is the DOM trick that you need to think about inside the object browser is how events wire up. So before I mentioned to you with function literals, the importance of using prototype to conserve memory. Well, the DOM actually has a similar sort of quirk around events. So you can imagine here I've got an unordered list here, and there's 3 anchor elements there, apples, bananas, and oranges. And so if I want to wire something up to that particular click event to fire off when I go ahead and click. And so traditionally you'd think, yeah, okay, that makes total sense. I'm just going to go ahead and say on click, go ahead and run this particular function. The problem with this particular event is what it's done in memory is it's actually created 3 instances of that function bound to each one of those instances of the anchor elements. And performance-wise, you're not going to see a problem on 3 elements. When you get to the hundreds or thousands of elements, that's a real issue. And so one of the things that jQuery makes it really easy to do is take advantage of event bubbling. And so what that is in the document object model on the browser side, when I click the anchor element that's inside a list tag, that's inside an unordered list, that's inside a nav, it's actually going to start bubbling up that event until somebody handles it. Or it gets to the top, in which case it says, nobody wants to handle me, I'll go do my default action. And so I can get this exact same behavior here of binding to each one of these anchor elements by simply binding to the nav with JavaScript and saying, I want you to run the click event, but only when it comes from an anchor, then run this function. And what this allows me to do is get the exact same behavior, but I'm only creating 1 instance in memory. So that's just something to kind of keep in the back of your mind when using jQuery with the DOM. To do it more efficiently, just remember, events bubble up. And so you don't want to bind to every single instance if you don't have to. Of course, jQuery makes things really nice when it comes to manipulating the DOM as well. So in this case here, I'm just going to add to the click event. And of course, every time I click, it's going to go ahead and change the CSS around it. Chances are in real life, you're not going to actually manipulate individual CSS elements. You'll just switch out CSS classes. But I just wanted to kind of show that as an example. And of course, jQuery itself has built-in animations. And so when I go ahead and click this, it goes out and shows and hides. So no longer do you have to handle some of those or write all the code for yourself. It's got a built-in toggle animation, which will toggle it. And of course, you can have fun with these animations. They don't have to be the boring built-in show and hide. This is probably one of my favorite April Fool's ones. So we like to inject that in. And so you can do pretty much anything you want with the animate function to really make it work. And of course, you can manipulate content inside in jQuery and inject new elements. And this is most useful when you're doing Ajax. So Ajax has become synonymous with jQuery because they've just built a nice API that makes it nice and easy to do. So I'm going to just go ahead, and, in this case, I'm just going to paste it in because I'm only about 5 minutes left here and I want to give away some prizes. But I've got an Ajax call out to this URL that's going to return me back JSON. And when I get back, go ahead and run this function. And this function is just going to basically peel through the data. Because it's JSON, it's able just to evaluate it as a native JavaScript object and allow me to populate the objects. And of course, if ICANN has cheeseburger, these will all start to look very familiar sometime soon. So that's a little bit of Ajax in action. Again, the likelihood that you need to get down to that level from a application perspective Depending on the control sets you're using, if you're using like Kendo UI from Telerik, they'll handle a lot of the AJAX for you. But quite frankly, it's very useful to understand always how things work under the covers. And so get to know the $.ajax. It's really super handy. Just before I wrap up, I just want a quick word on testing with JavaScript. It does exist. Like everything in the world of testing, it's not about 100% coverage. It's about managing risk. So for example, let's say I've written a function that I use in a number of different places. I've stored it inside a separate JavaScript file, and I want to actually test how it works. So we've got a test runner called QUnit, which is similar in concept to your NUnit, XUnit, MS test that allows me to go ahead and run those tests. And it's got a couple of different styles to work with. Kind of a hard and fast, kind of multiple assertions style, or probably a more familiar arrange, act, assert style that you'd be familiar with. And again, the concept is the same here in terms of, if you know how to do unit testing, you're kind of doing the same thing with the JavaScript code. The syntax is just a little more JavaScript-y. And then, as far as test runners go, I've got Just Code here, which actually has a built-in test runner around QUnit and Jasmine, which are two popular test runners. So I can just simply go ahead and run it as I would any other unit test, and it's going to come back and show me my successes and failures on a particular test in the web page which it executed or within the IDE. So very powerful stuff. And the final thing I'll just show you is just a Visual Studio tip, obviously, is JSLint. So this is effectively, JavaScript's an interpreted language. So it's not until runtime in the browser that you really actually know what's going to go on. And so JSLint is handy for being able to do some of that sniffing, that static analysis to figure out what's going on inside your code. And so they've got some standard rules in there. And if you're doing anything beyond just very basic JavaScript, I really encourage you to plug JSLint into your solutions. If you're using FXCop or the code analysis inside Visual Studio, this is your parallel for JavaScript. And you absolutely should be using it because it'll help you write better JavaScript. It's a free second set of eyes is how I like to bill it. And it's built inside Visual Studio, and people can you can build it into a build process and all the other fun stuff. All right. So just so you know, JavaScript itself as a language continues to evolve. ECMAScript 6 is on its way, and as you can see, we're still in early stages of actual implementation of it. But the point is, the language itself is nowhere near dead. In fact, it's only getting better with age. And so I really think this is something that, from an investment perspective, I hope you're here because, it's something that, you see as valuable and something that you want to invest in. So I'm going to wrap up and give away a couple of prizes. I've got a couple of T-shirts up here, and then I'll give away a Just Code from Telerik and a Kendo UI. I'll just need you to give me a business card, or I don't have a pen and paper up here, so you'll need to write down something to be able to give it to me. So let's see who was paying attention. So there's three kind of out of the gate, three types that JavaScript works with: strings, numbers, and what was the third one? Oh, sorry, too fast. I'm looking for hands. I heard that from here first. Come on up. I heard Boolean. So hands, please don't shout out because I can't look around that quickly. So if you want the Kendo or the Just Code, I need some sort of. Okay. Actually, I'll give you something to write something on, and I think I've got some of mine here still kicking around. So just write an email address, if you will, and which one you want. All right, so the next one I'll do is the control structures. There was a particular type of for loop that was interesting. Sorry, first hand here. For in, excellent. We'll come up and grab either a T-shirt or a prize, or if you want one of the other ones. It depends on what he's grabbing. Okay, and then you get the Just Code, and then everything else is T-shirts after this.